Welcome back to my channels and tutorials. I'm Sir Durba here, again ready to help you out with circles. Now, I believe that all of you have gone through the first video of my circles introduction. So I believe that all the theorems are all okay with you. So before we really begin, I believe that you are following this channel, and I believe that you have shared it with your friends also, so that they can also learn from this channel, at least during this time, for those who cannot attend these online classes and those who may be having problems with this network problems and many other problems. Some of your parents may be working, maybe at home, so because of that you may not be able to attend the online classes regularly on time along with your friends. So for those, don't worry, I am there. I'm here to guide you, and I'm here to give you almost everything. It's just that this is just the beginning part of my channel, so please see to it that you follow this channel. I will guarantee that most of the topics will be covered in a very short time. So that's why please do not forget to subscribe to the channel, so that you will get regular notifications on any new videos that comes up. Now, before we really go to the main solution part, the first exercise I haven't done for you, because the first exercise, like I think most of the questions we have already discussed in that activity-based class, in that first class, Introduction of Circles class. So we'll just go to exercise 10.2. Now, before we really go to that circles, let's try to recap some of the theorems that we have learned through our activity. Some of the theorems that we learned through our activity were, let's just do a quick recap. That is a circle, a center. If you draw a tangent to a circle, tangent means touching at only one point, okay? Then in that case, you join the center, the point of contact, then what happens is this is perpendicular to the circle. So the circle and the tangent will be perpendicular to the radius through the point of contact. This was one theorem. The other theorem was from an external point, from a fixed external point, we can draw actually only two tangents. Of course, if the point is not fixed for us, we can draw many tangents, right? But if we have only a fixed point given to us, then with that fixed point we can draw only two tangents, that is this and this tangent. And another thing that we learned was these two tangents, the length of these two tangents, of course, definitely will be equal in length. So these were some of the theorems that we learned, which we are going to be requiring in class 10 topic of circles. Anyway, let's go back to this question, the first question of exercise 10.1. So I believe that please get your pen, paper, copy, textbook, like everything ready. I hope you have done that. So if you're ready, shall we begin? Okay. The first question, that is exercise 10.2, class 10 mathematics, circles. From a point Q, the length of the tangent to a circle. So first we need to get our circle, a point P. The length of tangent from a point Q. So from a point, let's say from a point Q, the length of tangent. So let's say this is the one. From a point Q, the length of the tangent to a circle is 24 centimeter. 24 centimeter, and the distance of the point Q from the center, distance of the point Q from the center is 25 centimeter. 25 centimeter. Now the question is, what is the radius of the circle? So if I join, as we know through that theorem, the point of contact center, if we join, that becomes the radius. And another theorem that we have already studied was when I join the center, the point of contact, what happens? The angle that is being made at the point of contact by the tangent and the radius is how much? 90 degree. So what happens there? In that case, what happens is like this triangle becomes like a right angled triangle, isn't it? Then it becomes like this is like 90 degree, isn't it? So we can use Pythagoras theorem, but before we really jump into Pythagoras theorem, what we will do is maybe we will just redraw this figure properly so that it looks like a right angle triangle. So I'm going to cut off this triangle and then bring it in the shape of a right angle triangle so that it's going to be easier for me. So let this be the point O, right? Okay, let's name this as point P. So this will be point P. O, Q, anywhere you can name, no problem with that. So in that case, OP is the radius which we have to find out. OQ, 25, PQ, 24. I think that will help you much better. Please don't mind my diagram. Okay, like it may be looking something like this, but I need to draw a right angle triangle. I'll try to draw better. Okay, now let's start with the solution. So before we really go for the solution, let's say, okay, let's say QP is the tangent. QP is the tangent meeting the circle at P. So what will happen is OP, so OP will be perpendicular to PQ. Alright, OP will be perpendicular to PQ. The reason would be actually since the reason, I think I can rub off the question now, right? Less space, no? So quickly, so the reason would be since tangent, in short, no? Tangent is perpendicular, since tangent is perpendicular to the radius. Since tangent is perpendicular to the radius through the point of contact. Okay, alright, are you done? Okay, so let's continue. Then I'm going to rub off this. So what happens is angle QPO will be a 90 degree. Then triangle QPO is a right angled triangle. Are you done? Okay. If it's done, so applying Pythagoras theorem. So applying Pythagoras theorem. So applying Pythagoras theorem. Again, I'll rub this off. I hope you're done with that. Of course, you can pause, and then that's the advantage of this video. So you can just pause and then write down. No problem with that. So applying Pythagoras theorem, what will happen is, as per Pythagoras theorem, OP square plus QP square will be equal to OQ square. Now, generally, you must be wondering, like, see, we can also write like OQ square is equal to OP square plus QP square. Both are same, okay? It's like any way you can write, but what I do is I prefer to, for me, that's always like easier for me, because for us, like left to right, that's always like, left to right, that's always easier for us, the transition. So because here I can write it in both the ways, right? I'm giving you a small trick here. To help us simplify, because most of the times what I've seen is like generally like we transfer the negative signs from left to right. That's always easier for us. But again, to go from right to left, we're not very used to it. I do not mean to say that it is wrong. No, absolutely not. It's all the same. If you're comfortable, no problem with that. But like for those who are not very comfortable, what I try to do is I can use either one of this. So before I use that, what I try to do is I try to first think, what is the quantity that I have to find out? and the quantity that I have to find out, I try to keep that on my left hand side so that it is like easier for me to transit. So here what happens is I have to find out OP. So that's why I am using this side instead of this. If I had to find out OQ, definitely I would write in this form, no? So of course it doesn't make much difference. It makes my job a little bit easier. So now what is OP? Let that be the radius r square. QP, 24 square, that will be equal to 25 square. Alright, so that is going to be r square plus, now 24 square is like 576 and 25 square will be 625. I'm not writing down the units, okay, I'm ignoring the units. Alright, so r square will be equal to 625 minus 576. So that's the way, isn't it? It's much easier for me to move the equations from left to right. Like, it's always more comfortable for me. So now if you subtract r square, I believe like 6, 9, I think you're going to get 49. So what will be the radius here? Square root of 49. So that will be, of course, 7 centimeter. Now, of course, we can have for like plus minus 7 centimeter, but here we're talking about radius. So that's a unit of length. So unit of length will always be positive. So I generally ignore the negative side here. Okay, so that's going to be like 7 centimeter. Are you done? Okay. So please note it down. In the meantime, I'll prepare the other question. Okay, let's go to the next question, that is in the given figure. It's given that TP and TQ. It's given that TP and TQ are the two tangents to a circle. Are the two tangents to a circle. Are the two tangents to a circle with center O. It's always better to write down the question, okay, when we study, because don't study only the solution, so that in the exams, like, you know what happens with sometimes most students, sometimes what happens is then, okay, just let me finish this. Then angle PTQ, and angle PTQ is equal to, that's question mark, then angle PTQ is equal to, that is angle PTQ. So okay, this have to find out this. What was I telling you? Yeah, sometimes what happens is students, generally not only students, even us also, what happens is like we study in a hurry. Most of the time what happens is like we study the solutions, questions like Hale ek baar dekho, just go through the question once. And then like we just study the solution. So in the exams what happens is like we don't identify the question also. We were so engrossed in the solution that we forgot the question. So, and if there's a small twist in the question, then that's it, like game over, So it's always better to write down the question when we solve also. Read and write down, that'll always help you out, okay? So let's try to find out angle PTQ. So before really go for finding out angle PTQ, let's see what are the facts that we can get from this given question. What are the facts that we can derive from the given conditions here? So it's given that TP and TQ are tangents. So what happens is, as we have already studied in that theorem, this angle 90 ho gaya, this angle is also 90. Right? Chalo. Solution. I'll write that same sentence again. Since what? Tangent is, I'll write in notation, okay? Since tangent is perpendicular to radius through the point of contact. So OP means angle OPT is also equal to angle OQT is also equal to, both of them are equal to 90 degrees. Shall I write the question? That's equal to 90 degrees. Okay, we're coming to the solution. Okay, very simple question, very simple. And it's given that angle POQ is also 110 degrees. What are we supposed to find out now? This. Now, if you look at this figure carefully, you see how many sides does this figure have. I'll try to get some colored chalks, okay, so that it will be easier for you to, when I especially draw figures and all that. Kitna side? Let's count the number of sides this particular figure has. Like 1, 2, 3, 4. How many sides does it? 4 sides. Now what is a figure? What do we call that figure which has like 4 sides? So we call that as, we call that side as a quadrilateral, isn't it? So again, let's go back to some of the theorems again. We already know, the more commonly used, that the sum of angles in a triangle is how much? 180 degrees. What do we know about the quadrilateral? In the quadrilateral means any figure with 4 sides. Square, rectangle, rhombus, parallelogram. No, quadrilateral is a general name given to any figure which has 4 sides. So any figure which has 4 sides, the sum of the angles in a quadrilateral, how much? 360 degrees. Okay. So since PTOQ is a quadrilateral, angle PTQ plus angle POQ plus angle OPT plus angle OQT will be how much? 360 degrees. So we have to find out angle PTQ plus this is 110, this is 90 degrees, this is 90 degrees, this is equal to 360 degrees. Let's calculate that quickly. Angle PTQ plus 180, 280, 290, 360 degrees. So angle PTQ will be equal to 360 minus 290. So 360 minus 290, how much? 70, is it? Is it going to be 70? Please check once again, like 100, 200, 200, 200 plus 90, 290. So 290, 360, 360, 110 goes back up here. 70, I think it's 70 degrees, isn't it, Chalo? Okay, so that will be the solution. I think you can get your options in the questions. Okay. Let's quickly move to question number 3. Let's do it quickly. That is, if tangents PA and PB from a point B, PA and PB from a point P, from a point P to a circle, to a circle, to a circle, to a circle, to a circle with center O, with center O, are inclined to each other, are inclined to each other. English is very important, okay, to understand the question. No, at an angle of 80 degree, at an angle of 80 degree, then angle POA. Then angle POA is equal to, okay, that we have to find out. Then angle POA is equal to how much? I hope you've read the question again, once again. So if tangents PA and PB, so chalo, like one circle, let me draw one circle. Point P, one tangent point P, another tangent point A, B, chalo. I'll just join points of contact, perpendicular, automatic, na? Perpendicular, isn't it? tangents BA and BB from a point to a circle with center O are inclined to each other at an angle of 180. Inclined to each other at an angle of 180. So like it's like my fingers inclining to each other, isn't it? Inclining to each other at an angle of 180 degrees. So that is BA and BB. That is, this angle is 80 degree. Angle, you have to find out POA. So if I join this, that means I have to find out angle POA. How am I going to do this? I have to find out angle POA. Okay, how shall we do this? Quite simple again. 90 over here, 90 over here. This is 80. Full angle is 80. Now full angle is 80. Now what we will try to do is, shall we try to prove that this triangle, this triangle and this triangle, they are congruent. Very easy to prove. Congruent because nikal jayega. Because what happens is, like, congruency, this side equal, radius, common side. Very simple to prove. Congruency theorem. So chalo, let's just prove that. Solution. I'll tell you what happens. Let's try to prove. In triangle POA and triangle POB. There's one theorem to it also, but this time let's just prove, no? PA will be equal to PB, tangents from, I'll just write in shorts, no? Anyone can understand, tangents from P, no? Samajh gaya. OP equal to OP, so this will be common side, no? Common side. OA is equal to OB. They are both radii. Radii means plural form of radius. Singular means only one. When we have two, we use a plural form, isn't it? So radius. So we call it radii. So okay na? So triangle POA congruent to triangle POB by what? Side congruency criteria. Why? What happens when two triangles are congruent to each other? When two triangles are congruent to each other, what? When two triangles are congruent to each other, all the sides are equal, already proved. All the corresponding angles are also equal. So this angle is already equal, 90. That means this angle and this angle will also be equal, and this angle and this angle will also be equal. But I'm not very much interested with this angle. I'm more interested in this angle, because if these two angles are equal, this total angle was kitna tha? 80. So if these two angles are equal, that means 80 to half of, 50-50. So that means this will be 40, this will be also 40. Equal angles, isn't it? Equal angles. Total is 180, both of them are equal angles. So I have like 4 kg of wheat. If I have to distribute the two persons equally, so 2 kg, isn't it? So that means angle APO will be equal to angle BPO. Both of them will be equal to half of angle AP. Both of them will be equal to half of angle APB. So that will be half of 80 degrees, so that is going to be 40 degrees. So now why did I find this 40 degree? Because see, therefore this is already 90, this is already 40, 90. So what is this? In this triangle, angle sum property of a triangle, 180. So 180 minus 90 minus 40, this will be left. So that's what we are going to be doing. Also, but I forgot to mention, also OA is perpendicular to PA, no? Alright, tangent perpendicular to radius. I'm not going to write again, no? Tangent perpendicular to radius, because in the same video we have done that 3 times. So please make sure that you write it down, okay? Tangent perpendicular to the radius through the point of contact. Okay, so that means angle OAP is also equal to 90 degree. So in triangle POA, angle OAP plus angle APO plus angle POA will be equal to 180 degree angle sum property. POA. Right. So let's do it quickly. So OAP 90 plus APO 40 na? APO 40 yeah. Angle POA that one we have to find out. 180 90 130 angle POA 180. So angle POA 180 minus 130 kitna? 50 degree. I think your option is correct. Option A, 50 degree. Okay, so that's how it. That's why I was telling you, geometry is not very difficult. No, you have to just proceed step by step, one by one. We have to proceed. Remember all the theorems, because theorems are like very important for geometry portion. So that's it. So okay, so if you have liked this video, please hit the like button, subscribe, share it with many of your friends so that everybody can benefit. Okay. So thank you for being a part of this video. I'll see you again in the next video with the next questions. Take care all of you.